This video is an introduction to right triangle trigonometry, focusing mostly on sine, cosine, and tangent. These three functions are often abbreviated as sine, S-I-N, cosine, and tangent. Even though this looks like sin, it's pronounced sine. We're going to go into a menomnic that if you're in, say, high school geometry or trigonometry course, maybe you've heard of this, or maybe in a pre-calc course, SOH CAH TOA. We'll go into that. So going over some basic right triangle information here. Oops. We have a right triangle, and in a right triangle, this little corner here that's 90 degrees often is sort of boxed out, and that signifies that's the 90-degree angle in your triangle. The side that's opposite that is the hypotenuse. So if you were to draw a little arrow through the corner of the box and keep going, you're going to hit the hypotenuse. In trigonometry, we often focus on one angle in a right triangle, and in this case I'm going to call that angle alpha. I'm going to label it with a little hash mark here. Depending on your course, you could call it theta, you could call it angle A if this was labeled with an A or with a theta. Doesn't matter, we're going to call it alpha in this case. For our purposes, normally in a right triangle there's a hypotenuse, and these are called the legs. For trigonometry, we focus on a certain angle, a certain one of the two acute angles, and then the side that is adjacent to that angle, or attached, so I've heard some students call it attached, is called the adjacent side. And the side opposite that angle is called, guess what, the opposite side. And these trig functions have to do with how this angle is in proportion to these sides. So the sine function, the sine of alpha, is the opposite over the hypotenuse. So if we had measurements for the opposite side and or the hypotenuse, we could figure out what this angle was. Or if we have this angle and this opposite side, we can figure out what the hypotenuse is. The abbreviation would be SOH, S-O-H, to remember this. Cosine of alpha, the cosine of this function, is the adjacent side over the hypotenuse. So adjacent over the hypotenuse, and that would be CAH. And then the tangent of alpha is the opposite side over the adjacent side. And this is where we get TOA from. So let's, actually, before we go into some problems, let's consider how do we decide which is the adjacent side and which is the opposite side? Well, it depends where we place the alpha. For example, in this triangle, here's the right triangle, the right angle. I've chosen this as my alpha, and the side opposite that is over here, and the adjacent side is here. The hypotenuse, of course, is always opposite that right angle. Down here, for this triangle, your triangles aren't always going to be drawn with one of the legs parallel to the bottom of your page. Your triangle could be drawn this way. However, what's important is where is that right angle, and that the side opposite that right angle is a hypotenuse. They often will tell you which angle you're dealing with. Here's the angle alpha, and the side opposite that is opposite, and the side attached or adjacent is indeed right next to it. So I hope that helps if you're not sure which is the attached or adjacent and which is the opposite. So let's launch into some problems here. Got our right triangle, our right angle. Let's say we're given that this angle here is 58 degrees. And we're also going to be given that this is the side we want, x, and that our hypotenuse, in this case, is 120. So we have to say, well, do we want to use sine, which is opposite over hypotenuse? Do we want to use cosine, which is adjacent over hypotenuse? Or do we want to use tangent, which is opposite over adjacent. Well, let's see. Here's our angle, 58 degrees, the side opposite that, opposite. So I have to deal with the opposite, and I'm also given the hypotenuse. Looks like sine will work. So sine of 58 degrees equals opposite, which in this case is x, over the hypotenuse, which is 120. Now to solve this, we need to isolate the x. So it would be helpful to multiply both sides by 120 to clear that. We're going to then get 120 times the sine of 58 degrees equals x. We punch that through on a calculator, and we get that x equals approximately 101.8. So that's an example for the sine function. Let's pretend that we have I'm going to deal with a different angle this time. We're going to pretend this is the angle that concerns us. We'll call it, again, alpha, and that alpha is 35 degrees. And that we're also going to be given that this leg is 10 units, whatever that is, and this is going to be our hypotenuse. So we want to solve for h here. So we're given an angle, okay, and we're given an adjacent. So it looks like cosine is going to work. Adjacent over hypotenuse, this is what we want to use. So cosine of 35 degrees equals the adjacent, length of the adjacent leg over the hypotenuse. We can keep calling that h. When we want to solve for h here, we can do a simple switch of switching the h into cosine 35 degrees, and that would take care of it. But if you're not that fast with your algebra, let's do it this way, one step at a time. We'll multiply both sides by h, and that's okay. You know, take your time with these. Do baby steps until you're really comfortable with this. We're going to get h cosine 35 equals 10. Well, we still want to isolate that h. Let's divide both sides by cosine 35. We're going to get h equals 10 over cosine 35, which if we punch that through on a calculator, we get approximately 12.21. There's a cosine, example of cosine. I think if I'm very quick, I can do a tangent example. Let's see. Let's say that we have that, let's deal with this angle again and not this one. We are going to call this 21 degrees, we're going to call this x, and we're going to call this 100. So this is actually a almost realistic problem. You've got 100 feet to the cliff. You want to know how tall the cliff is, and you have, say, a Brunton compass. You can measure the angle to the top of the cliff is 21 degrees. So I know we're going to use a tangent function here. The tangent of 21 degrees equals x over 100. That's opposite over adjacent. Clearing this out, we get 100 times tan 21 equals x. So x equals, as we push that through on a calculator, approximately 38.4. I hope this helps. Enjoy, and thanks for watching.